All right, y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, unpause the video, and I'll show you how to work those two. So for the factoring, you're going to have x squared minus 6 and plus 6. And then neither one of those will factor any further, so you'll leave it just like that. For the math knowledge question, all you're going to do is solve this inequality. So I'm going to take 3x minus 7 less than 5 plus 9x, and I'm going to subtract 9 and get negative 6x and add 7 to have 12. And then if I divide by negative 6, this sign has to switch directions, and so you have greater than negative 2. And so your answer, they wrote it with the x on the right side. So if you flip it around, your answer is going to be A. We're looking at lesson 63 today, the critical number or the closed interval theorem. So hopefully after this lesson you'll understand the critical number, the closed interval theorem. Looking at the maximum minimum value existence theorem, it says that a continuous function must have both a maximum and a minimum value on any closed interval. So I'm going to draw you a graph. I'm going to do a quartic, and it's a positive one. We have learned this year that this graph gives us one max value here, a relative max, and then we've got a relative minimum here and here. And we've learned how to find those. This maximum minimum value existence theorem says that no matter where your closed interval is, if you have a continuous function, you're going to have a maximum and a minimum. Take from this value to that value, for instance. Well, the minimum is right here, which happens to be our relative minimum. The maximum value, though, it starts here, and then it gets all the way up to this point. And so that would be the maximum value for that closed interval. Now, if I move over from here to positive infinity, my minimum value is going to be this point here, and then my max value would be infinity, because it just keeps going on and on. But if I stopped it here now, the max value is going to be at that value. And so no matter where your interval from A to B is, you're always going to have a low point and a high point. Think about classrooms in the school. No matter which classroom you go to in the school, no matter where you are, look at a test grade for that particular class. There is going to be a lowest grade and a highest grade every time. You're going to have something that's the lowest and something that's the highest. And so that's basically what it's saying. If your f function is continuous on the closed interval from A to B, then it obtains a maximum value m and a minimum value little m on the interval. Okay, so that's the maximum minimum value existence theorem. So looking at the critical number theorem, if f is a continuous function on a closed interval, and if f obtains a max or min value at x equals c, where c is in the interval, then either c is an endpoint, the derivative does not exist, or the derivative equals 0. And so that's what you're going to have to look at. Your endpoints, where your derivative does not exist, and where your derivative equals 0. In the past, when we found our relative max or mins, we have just looked at where the derivative does not exist or where it equals 0. We just take the derivative and set it equal to 0, and that gives us our max or our min values. But now that we're going to have endpoints, we're going to have to check to see if possibly the endpoints are maybe a max or a min value. So let's look here. We want to find the maximum and minimum values of this function on the interval from -2 to 4. So the first thing that you're going to do is to take the derivative. So if you take the derivative, you'll have 6x squared minus 6x minus 12. And so if you factor out a 6, we end up with x squared minus x minus 2. We can set it equal to 0 now. And this will factor further as x minus 2 times x plus 1. And so my x values are 2 and negative 1. So those are my critical numbers. And we want to find the max and the min values of our function on the interval. So what we need to do, we're going to check 2. We're going to check negative 1. But we also have to check the endpoints of negative 2 and 4. And so you're going to plug each of those 4 values into your f of x function, the original one there. And so if you plug in a 2, you're going to have 16 minus 12 minus 24 and plus 1. So you're going to get negative 19. If you plug in negative 1, you're going to have negative 2 minus 3 minus 12 and plus 1. I'm sorry, plus 12 and then plus 1 to get a positive 8. If you plug in negative 2, you'll have negative 16 minus 12 plus 24 plus 1, which will give you a negative 3. And then if you plug in 4, you're going to have 128 minus 3 times 16, which should be 48, and then minus 12 times 4, which is also 48, and then plus 1, you'll get a 33. So the way that you determine if you have a max or a min, you look at the y values. The smallest one is your minimum, the largest one is your maximum. So the smallest one of these is negative 19, so this is our minimum, and the largest one is 33, so that's our max. So those are your max and your mins. So on these, you're not going to have multiple max and mins. You're usually just going to have one max and one min, unless you had the same exact y value for some of your functions. Looking at the next example. We have a 10-inch long string that's cut into 2 pieces. One of the pieces will be bent to form a square, and the other will be bent to form a circle. We want to figure out where the string should be cut to maximize the combined area of the circle and the square. So here's what I'm going to do. I've got a circle, and I've got a square. We are wanting to maximize the area. So we're going to need to find our area. So I've got the area of the circle and the area of the square. Now, we know for a circle we have an R, and for a square we have an S. And we know that together the perimeter of the circle and the square is going to have to be 10. Because that's all of the string that we have. So we want to figure out how to put R and S into one variable, and we're going to start by using our perimeter formula. The perimeter of a circle, or the circumference, is going to be 2 pi R, and then the perimeter of the square is going to be 4S. And so we know that 2 pi R plus 4S is going to equal 10. We can either solve that for R or for S. I'm going to solve it for S. Just so that I don't have pi in my denominator. But it really doesn't matter which one you solve it for. You can work it either way. Now looking at our area formula. The area for a circle is pi r squared. The area formula for our square is the side length squared, because it's the side times the side length. Right now those are not the same variables, but we can plug in s and put it in terms of r. And we can go ahead and reduce that 10 over 4 to 5 over 2. And then we have minus pi r over 2. And we're going to square it. So that's going to be your area. And now to maximize it, you're going to take the derivative. So the derivative of pi r squared. Well, before we do that, let's go ahead and distribute. Well, we don't have to. We can leave it if y'all would like. We can say 2 times 5 over 2 minus pi over 2r, and then times the derivative of the 5 over 2 is 0. Derivative of negative pi r over 2 is negative pi over 2. That 2 here and that 2 there will cancel. So we're going to have the derivative as 2 pi r, and then 5 over 2 times negative pi, and then plus pi squared over 2 times r. So now we need to set that equal to 0. And I'm going to put my negative 5 over 2 in front. Then I'm going to have plus 2 pi plus pi squared over 2. All of that is multiplied by r. So I can add the 5 over 2 pi, and then 2 pi plus pi over 2 squared. And so that's what I'm going to divide by. And it's just the pi that's squared. So now you need to plug that into your calculator and get an r value. You need to be very careful when you plug that into your calculator so that you get the correct answer. So if you solve it for r, you end up getting 0.700. And so that is a critical number. So now that we have our critical number, we're going to plug it back into our area formula here. And so we're going to do the area of our circle and our square, and our radius, or our r, is a 0.7. And if you plug that into your calculator, you should get 3.5006. If you look in the book on page 328, they have a critical number of 4.3990. And when they use it, they get the exact same area that we got. The reason that they get a different critical number is because they set up their formulas a little bit differently. They used an x, if you flip back a page, they used an x to represent the circumference of the circle, and then they used 10 minus x to represent the perimeter of the square, whereas we set those two added together equal to 10. And so that's why they have a slightly different critical number than us, because they set up the problem differently. But you'll notice that we still got the same area there. So now we need to check our endpoints. Well, the endpoints for this are going to be a 0 and a 10. And you may be wondering why 0 and 10. Well, if we have a string, technically we could cut it here, or we actually don't cut it. Or we could cut it here, where again we actually don't cut it. And what that would mean is we either put all of the string to making a circle, or we put all of the string into making a square. And so if you let your R be a 0, you're going to get 6.25. I'm still using the same formula right here. And then if you let your R be a 10, you should get a 7.9577. Well, of those, the largest area is this last one. That's the max value. So looking up here, it says, where should the string be cut to maximize the combined area of the circle? Well, we want to cut it where it is a maximum of a 10. And what that means is we're actually only going to be making one figure. And we're going to use the entire string to form a circle. Because when our R is a 10, when this is actually a 10, that's when we have the biggest area. Well, our R isn't actually a 10, but the whole part of it is used to make the circle. If you have an R of a 0, that's when it's the smallest area. So that's how you would want to set that up. Okay, so looking at the next example, we want to find the max and min values of f on the interval from -2 to 3, where our function is x to the 2/3. So what we're going to do is take the derivative, and we have 2/3 x to the -1/3. And so now we're going to write it as 2 over 3 and the cube root of x. Now, this will never actually equal 0 because there's no way to make that actually equal a 0. The part that you're going to look at, I'm going to go back in your notes real quick, is this one right here, number 2. Where does our derivative not exist? Well, on this one, you cannot have your denominator equal 0, so x cannot equal 0 here. So that is a critical number. So we're going to test out 0, which is our critical number. We're going to test -2, and we're going to test 3. And you're just going to plug them in here. Well, 0 to the 2/3 is just 0. -2 to the 2/3 is 1.5874. And then 3 to the 2/3 is 2.0801. So of those, this is going to be our minimum. And then this one is going to be our maximum. Because that's our lowest and that's our highest value. So that would be your max and min values on that interval for that function x to the 2/3. Looking at this next one. A function f is continuous on the closed interval from -2 to 4. Also, f of -2 equals 2, and f of -1 equals -1, and f of 4 equals 5. Those are 3 points that are going to be on our graph. Then it says, furthermore, the derivative and the second derivative have the properties as indicated in the table. And we want to find where it obtains a minimum and a maximum on the interval from -2 to 4. So what you're going to want to do on these is actually do a little graph. Alright, so there's my graph. You want to go ahead and do these 3 points because they are points that are going to be on your function. We have -2, 2. We have -1, -1. Then we have 4, and 5. So we know that our function goes through those 3 points. Now we want to look at the derivative and the second derivative. Well, on the interval from -2 to -1, the first derivative is negative. That means the slope is negative. So that means that it's going down from one point to the other, which if you look, going from this top point, you have to go down to get to that bottom one. And then it also tells us the second derivative is negative. Well, that's dealing with concavity. And so concave down is going to be something that looks like this. And so you're going to make it look kind of like that. At -1, it's undefined for both the slope and the concavity. That means it's going to be probably a sharp point there. Looking at the part from -1 to 2, we have a positive slope, so that means it's going up, but its concavity is still negative, so it's going to look kind of like this. And that's from this point at -1 to 2. So I don't really know how far it goes up. I may have to erase that and redraw it, but it kind of looks something like that. And then at 2, it's a 0 for both the derivative and the second derivative. And then from 2 to 4, it is positive, so it's increasing, and it's concave up, so it's doing it like this. So what that looks like is something like that. And so it hits a flat part here, and then it starts increasing right at 2. So that's the basic shape of the graph of the function. It wants to know where does it obtain a maximum and where does it obtain a minimum. Well, the minimum is this point right here, which is -1, -1. And then our maximum is this point right here, which is 4, 5. And so that would be your answer along with the graph. They really like to put these on the test and on the homework. They're kind of fun. You got to do a little bit of deductive reasoning to figure out what the graph looks like. Once you have the graph, then the max and the min are pretty straightforward. But if you don't ever do the graph, then it's kind of hard to figure out what the max and the min are going to be for your function. Okay, so that's how you deal with your critical numbers on your closed interval. You don't have any to omit on your homework, so make sure to do those tonight, and then we can go over any of them that you have a question about tomorrow.